China has successfully put another probe on the moon. Its robotic Chang'e 5 mission touched down on December 1, 2020, with the aim of collecting samples of rock and dust to bring back to Earth. The venture has targeted Mons Rümker, a high volcanic complex in a nearside region known as Oceanus Procellarum. The lander is expected to spend the next couple of days examining its surroundings and gathering up surface materials. It has a number of instruments to facilitate this, including a camera, spectrometer, radar, a scoop, and a drill. The intention is to package about 2 kilograms of soil or regolith to send up to an orbiting vehicle that can then transport the samples to Earth. It's 44 years since this was last achieved. That was the Soviet Luna 24 mission, which picked up just under 200 grams. Follow me on this journey to learn more about this amazing mission program and to understand how we accomplished this goal. We made it thanks to the hard work made by Chinese engineers during the last 20 years. Chang'e 5 was launched on November 23, 2020, and landed on the moon on December 1, 2020, with an expected return to Earth around December 16, 2020. Chang'e 5 will be China's first sample return mission, aiming to return at least 2 kilograms, 4.4 pounds, of lunar soil and rock samples to the Earth. Like its predecessors, the spacecraft is named after the Chinese moon goddess Chang'e. This is one of the missions that we were waiting for a long time. We really couldn't wait for this mission to be launched. This will be the first lunar sample return mission since Luna 24 in 1976, and if successful, would make China the third country to return samples from the moon after the United States and the Soviet Union. It launched from the Wenchang Satellite Launch Center in Hainan Island. Missions like this are awesome missions. You can choose the place you want for landing, dig a nice hole in the lunar soil, and take some rocks and stuff from its surface. Then you could finally launch a rocket that reaches an orbit around the moon, make it hooked to another spacecraft, and then launch it on its way back to Earth. And if everything worked out well, you can return in the Earth's atmosphere. Where the heat shield does its work and returns home, carrying the sample that until a few days ago was on the moon. But let's go deeper into this mission. What's the Chinese plan? This is the 6th Chang'e mission, and it's called Chang'e 5. I know this could be a little bit confusing, so let's see some of Chang'e's mission's history. China has been carrying out this mission program since 2007. That was the first time China had accomplished something so big. Chang'e 1 was thought to have launched to orbit around the moon, helping engineers to improve their skills and experience before launching the second mission, Chang'e 2. Chang'e 2 was launched in 2010, and after its success in the lunar orbit, China tried to see if they could reach Mars with another probe. And some years later, that's what they actually did. The mission named Tianwen-1, which means questions to heaven, is the country's first attempt to land on the red planet. And then it was time for Chang'e 3 to map the moon. It let China find the first landing sites for the moon landing. Chang'e 3 even brought a rover to the moon in 2013. This was something which has not happened for several years. When they finally found a good crater to land on, Chang'e 4 was launched, and it landed on the dark side of the moon, a place that has never been explored before. So as you can see, the entire program was made of 3 steps. 1. Orbit the moon. 2. Moon landing and exploration. 3. Bringing home moon samples. Chang'e 5 is the first one that will try to complete this third part of the mission program. But actually, it's the second one, because Chang'e 5 had an older brother, Chang'e 5 T1. Chang'e 5 T1 was an experimental robotic lunar mission that was launched on October 23, 2014, to conduct atmospheric re-entry tests on the capsule design planned to be used in the Chang'e 5 mission. Its service module, called DFH-3A, remained in orbit around the Earth before being relocated via Earth-Moon L2 to lunar orbit by January 13, 2015, where it used its remaining 800 kilograms of fuel to test maneuvers key to future lunar missions. So we can say that Chang'e 5 T1 was a test to make sure we could complete successfully Chang'e 5's mission. If you had to launch a hippo, you first have to be sure that you can bring the hippo back. Chang'e 5 T1 also tested the re-entry phase of the mission. The re-entry phase is one of the most difficult goals to accomplish for the Chang'e program, because it isn't easy to create the right conditions in order to have a safe re-entry in the Earth's atmosphere. Also, the re-entry method that will be adopted for the Chang'e 5 capsule will be similar to those technologies that will be deployed by the astronauts returning home from the moon in the following years. Dockings, rendezvous, maneuvers, they will be exactly the same as the ones that will be used in the next human missions. So for this mission, it is also a way to test what we have to do to enhance our performances and skills in human exploration missions. Before finding out more about the Chang'e 5 mission, be sure to like or dislike the video so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel, clicking the bell so that you don't miss any of our weekly videos. What is the Chang'e 5 spacecraft design? The Chang'e 5 spacecraft consists of 4 modules: a service module, a return vehicle, the lander, and the ascent vehicle. Overall, the spacecraft will have a launch mass around 8 metric tons, requiring a larger launch vehicle than previous missions. It is expected that the Chang'e 5 and 6 will launch on the Long March 5 rocket that delivers the craft to a direct trajectory to the moon. The Chang'e 5 service module includes all systems to support the assembled vehicle on the way to the moon, remain in lunar orbit for an extended period of time while surface operations are in progress, rendezvous with the ascent vehicle in orbit, and support the return vehicle during the transfer back to Earth, setting up for re-entry. The service module is equipped with power-generating solar arrays, communication systems for command uplink from Earth and telemetry downlink, as well as a propulsion system and attitude control thrusters, likely based on propulsion technology already used on Chang'e 3. The vehicle will use hypergolic propellants consumed by a throttle oval engine, likely the 7.5 kN engine used on Chang'e 3. The propulsion system of the service module would be used to conduct trajectory correction maneuvers on the way to the moon, the lunar orbit insertion burns, orbital maintenance, and the trans-Earth injection burn at the end of the mission. The service module directly interfaces with the return vehicle that is installed in a cavity of the service module to reduce the overall length of the vehicle. The return vehicle is equipped with a modified heat shield to be able to withstand the re-entry into the Earth's atmosphere at speeds of 11 kilometers per second. Landing is accomplished using parachutes that are deployed during atmospheric flight, starting with a drogue followed by the main chute. The return vehicle includes a thruster system to actively control its orientation before re-entry and modify its re-entry path by adjusting aerodynamic lift to target a reasonably sized landing zone. Onboard measurement systems and communication beacons for the location of the landed vehicle are also part of the entry vehicle. It is likely that the goal of the mission is to complete all sampling and drilling operations within 1 lunar day to avoid risking hardware damage as a result of the harsh temperatures of the lunar night. After sampling and transfers of up to 2 kilograms of lunar material to the ascent vehicle is complete, all preparations for the return journey will be completed. The ascent vehicle will then use its propulsion system to ascend into an orbit of 15 by 180 kilometers and further raise its orbit and complete a fully autonomous docking with the service module return vehicle stack. Re-entering at a speed up to 11 kilometers per second, the return vehicle would utilize a skip re-entry. But how does a skip re-entry work? Well, imagine a pebble thrown into a small circular pond. It's pretty much the same thing. When the capsule reaches the atmosphere, the temperature on the capsule is so high that the heat shield may literally fuse. So one has to re-enter the atmosphere, decreasing the amount of heating exposure time in order to avoid really bad things. The basic concept is to cut the atmosphere at a certain angle so that the aircraft is pushed out into space, as happens when a pebble jumps over the surface of a lake. Each time the speed of the probe is reduced so that it can eventually descend into the atmosphere at a low suborbital speed. Like air capture, skip re-entry requires precise guidance. An excessively low entry angle will lead to a shuttle speed that is too high, with the possibility of permanently exiting into space if the vehicle exceeds the escape speed. An entrance that is too steep, however, will produce more intense heating, and the thermal stress could exceed the limits for which the shuttle is designed, with the possibility of destroying it. The skip re-entry was first imagined in the 1930s when a leap suborbital trajectory was designed for the German bomber Silbervogel, which never flew. The technique was used for the probes of the Zond program in flights around the moon, which involved a jump before landing. Jumps Zond 6 and 7 were a success, although the Zond 6 was largely destroyed in the impact to the ground for independent reasons. Interesting fact, on its trip, the Zond 7 craft carried 4 turtles. By the way, if everything goes according to the plan, Chang'e 5 will ditch into the ocean, and finally, it will be rescued, bringing the rock samples to the laboratories to study them. That's all for this video. Thanks for watching, everyone. What do you think about Chang'e 5's mission? Do you think it will be useful to future Moon and Mars missions? Let us know in the comments below. See you next time on the channel.